I will first start with the introduction. We chose the country Singapore as a subject for this assignment because it is a highly developed and densely populated city-state, making it an ideal case to study urban population trends. It is well known for its modern infrastructure, strategic location, and strong role in global trade. The data for the study was obtained from the Macro Trends website. We collected 21 sets of population data covering the years from 1982 to 2002. Based on this data, we aim to analyze how Singapore's population has changed over time. Overall, the trend shows that the population has been steadily increasing, reflecting continuous urban growth and development. Next, this slide shows the data table used in our analysis. The table includes three main columns: the year, the population for that year, and time represented as t in years. The time variable starts from 0 in 1982 and increased by 1 each year up to 2002. From the data, we can observe a clear upward trend in population. For example, the population was about 2.6 million in 1982 and increased to over 4.1 million by 2002. Although there are slight fluctuations in some years, the overall pattern shows consistent growth. This suggests that Singapore experienced steady population expansion over this 20-year period. This data will later be used to model and analyze the growth pattern more accurately.
Alright, for this part, I'm determining the exponential model for the population. We start with the standard exponential equation, P equals to AE to the power of KT. At T equals to 0, which is the year of 1982, the population is 2,646,466. So when we substitute T equals to 0, P equals to AE to the power of 0. And since e to the power of 0 equals to 1, we get a equals to 2,646,466. The next, we use data from the year 1983, where t equals to 1 and the population is 2,681,061. We substitute into the equation 2,681,061 equals to 2,646,466 e to the power of k. To find k, we divide both sides. E to the power of k equals to 2,681,061 divided by 2,646,466. Then we take natural log, k equals ln of that value, which gives k approximately 0.01299. So the final exponential model is P of t equals to 2,646,466 e to the power of 0.01299 t. Right, for this slide, I am applying the exponential model to estimate values outside the given data range. Our data only covers from t equals to 0 until t equals to 20, which represent the year of 1982 to 2002. So first, for the future prediction, I let t equals to 21, which represent the year of 2003. Substitute into the model, P equals to 2,646,466 e to the power of 0.01299 times 21, which give the value of 3,476,462. And next, for the past estimation, I let t equals to -1, which represent the year of 1981. Substitute into the model, P equals to 2,646,466 e to the power of 0.01299 times -1, which give the value of 2,612,310. This method is called extrapolation, where we use the model to predict values beyond the observed data, assuming the growth rate remain constant.
Hi, I am Marsha Christina and I will be presenting our graph. The red line represents the estimated population value while the black line shows the actual data. Both graphs are exponential, with the x-axis representing the years and the y-axis representing the population of Singapore. From the graph, the estimated value increased in line with the actual data. However, as the years progress, the estimated value begin to show a slight deviation from the actual data. This slight deviation may be influenced by several global factors.
Slide, which is step 6, analysis and discussion. The first question is, Are the values calculated from the particular solution consistent with the actual value? The answer is yes, although it is not perfectly consistent as it follows exponential models. As time increase, which is from t equal to 0 to t equal to 20, the estimated values begin to slightly deviate from the actual data because it is may be affected from the aspect like migration, government policies, or economic changes. The second question is calculate the percentage error. By using formula percentage error equal to estimated value minus actual value per actual value times 100%, and we use t equal to 10, which is year 2012 from the estimated data, we get 6.72% percentage errors.
For question number 3, if there are differences between the actual value and the calculated value from the particular solution, what are the possible reasons? So first of all is the rounding error. Round-off error comes from the hardware. Computers store numbers in binary format. If our calculation involves lots of decimal places like 1.001, the computer might just see 0. Second of all is sudden event. If there are any unexpected event happen during that range of the year that we choose, it might affect the population growth and also affect the particular solution. For question number 4, what factors have influenced population growth in the past? First of all is the colonial era 1890 to 1942, mass immigration. Initially, this group was driven almost entirely by male laborers who intended to make money and return home. Because there are very few women, the natural birth was incredibly low, and population growth relied entirely on new arrival. Second of all is post-independence, extreme population control, 1965 to 1980s. The Stop at 2 campaign launched in the late 1960s and 70s. The government used aggressive campaign and heavy disincentive to discourage large families.
Last but not least, the question asks, what do we think factors that may affect the population growth in the future? The first one is, of course, the fertility rate. Increasing birth rates contributes to a gradual rise in overall population in Singapore. The second one is high immigration rate, which is the inflow of foreign workers to support national development in Singapore, as well as the growing trend of international marriages will further boost the population rate. And the last but not least is economic development, which is the rapid economic growth experienced in the late 1980s created improved employment opportunities and higher income levels, which positively influence future population expansion in Singapore.
Lastly, we conclude that this study shows that Singapore's population experienced a steady increase from 1982 to 2002, which can be effectively modeled using an exponential function. The particular solution obtained provides a reasonable estimation of population growth, although they are slightly different from the actual data. This difference can be attributed to factors such as rounding errors and unexpected real-world events. Furthermore, population growth is influenced by various factors over time. Historical influences such as migration, patterns, and government policies play a significant role, while the future growth will likely depend on fertility rates, immigration, and economic development. Overall, also mathematical models like the exponential model are useful in predicting trends. They cannot fully capture all real-life variables, therefore such models should be used as an approximation rather than an exact prediction of population changes. That's all from us. Thank you.